add that number in as well. So if you think you're going to get confused applying that rule, just plug in the numbers and work it out. Whichever one will get you the right answer every time is what I want you to do. Know your own strategies. I want to do one of these with some addition at the end. So I want to do number 41. Okay? Does that make sense? Again, if you didn't have this done or done correctly on your homework, you should be scrambling to write it down right now. So 41 is y equals 4 times 2 to the x minus 3 plus 1. Okay? You guys ready?
So I have a question.
Yes.
Is it plus 1 just the other than the part of the equation, the asymptote?
That's going to be the new asymptote, yes. The plus 1.
So like if you get
Can't go under it, actually. In this case, this is going to be above it because 4 is positive. Remember the general form, which is y equals a times n to the x minus k plus h. If this is positive, it's the one going up. If it's negative, it all goes down.
Okay.
All right? Now, what's the parent function here?
Y equals 2 to the x.
Very good. Y equals 2 to the x. And the parent function would give me, the 3 points I'd be most interested in are the negative 1, 0, and the 1, which would give me 1/2, 1, and 2. Hope you guys are starting to see the pattern here. All right, now, I'm going to try and talk you guys through the sort of...
Oh wait, I have a question.
I'm going to try and finish a sentence someday, if Jordan will let me. Yes, Jordan, go ahead.
For the minus 3, make it a plus 3, and then you add it.
Yes, that was more of a statement than a question.
What was it?
Though your hesitant, unconfident inflection at the end made it sound sort of like a question. Okay, so for this one, y equals 4 times 2 to the x minus 3 plus 1. What we're going to do here, like Jordan just said, is we're going to add 3 to each of these points. Jordan, what's negative 1 plus 3?
You do 0, 1, 2. So
Yeah, 0, what, negative 1.
No, it'd be 2, 3, 4.
Very good, 2, 3, 4. That's what I was asking for. Good.
Wait, how do you know?
Yeah,
Because we've added 3 to each of these points.
You make it a 0 first, and then the 1 and the 2, right? You know what I mean? You make it a 0 before you
Yes.
make the 1.
Yes. Okay, now I get what you're saying. Okay, so Laura, this is an x minus 3, right?
Mm-hmm.
Whatever's happening to the x, switch the sign. So make this a plus 3. And then add it to your negative 1, 0, and 1. So negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. Where did I get the plus 3 from? I switched the sign on the x. Okay, now, you can plug this in from here.
Why would they just make it that sign in the first place? I don't get it. Like, you're not...
There's a reason why it always has to be opposite, and it would take me too long to explain. Okay.
There's a reason. Like,
There's a reason, yeah. It has to be opposite, actually. It has to do with the nature of functions, but I could show it to you, but it would take too long, and it's a secret, so then I have to kill you. Now, what's going to happen here is these numbers here, if you plug it in, you're going to get the 1/2, the 1, and the 2 again. They're all going to get multiplied by 4 and then have 1 added to them. So if you don't want to plug it in, you can just say, okay, what's 4 times 1/2? Well, what's half of 4? 2. What's that plus 1?
3.
So that's what's going to happen. After you do this change, you can just take this 4, multiply it by this number, and then add 1 to it.
What about the 2 and the...
What happened from the adding 3 is that gave us the one that the way this will work out every time, Jordan, I promise, is this 2 to the x minus 3 now with the 2, 3, and 4. This part will become the 1/2, the 1, and the 2.
But if you plug it in anyway...
You'll get the right answer every time.
Okay, so...
So that's, yeah, you don't have to follow it this way. But just this will now become 4 times 1 plus 1, which is 5. And this will become 4 times 2, which is 8, right? Plus 1, which is 9.
Wait, what?
What's 4 times 2, Ryan?
Oh, okay, wait, never mind.
8 plus 1. Okay, so these are the numbers you'll get. That's the trick you can use, or you can plug it in every time if you find that confusing. Okay?
So I can't go over the 1, right?
Can't go under the 1.
That's what I meant.
Okay, so now our new asymptote. This is what Jordan has been asking about, because she wants to be sure she gets this one right. Our new asymptote is the horizontal line y equals 1. So this exponential equation must stay above it. Must stay above it. You guys think you can handle that?
Then do you put the little end of the like the arrow above that too?
Yeah.
Okay.
This is the new thing it snuggles up to. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now at 2, we are up here at 3. At 3, we're up here at 5. And at 4, we are up here at 9. So it looks something like that.
You just put the arrow on the other side.
Yep, got to put the arrow on the other side. Questions on that? Thoughts? Nimi? You have a very interesting look on your face.
No.
Okay, so that's how you would graph these. And these are the 3 points I'm interested in. Right. Yeah. I'm interested in the points 2, 3, 3, 5, and 4, 9. Okay, so that's what I wanted to see on 41 and 35, and now we're going to start some word problems with this.
On the test, you have to graph, like, write the points.
Ooh, word problem.
I'm not sure yet. I may make it the rule where if you know you're so neat that I'll be able to tell, you don't have to, but if you think there's any doubt, you better label them or else I'll...
Smack.
They're right there.
You know we're graphing.
Okay.
Didn't math teacher, you're supposed to know.
That's right. Don't you know where... I actually got that from a kid in middle school once.
Really?
Don't you know what the answer is? Why are you asking me?
It's all a joke.
I'm honestly not sure in that kid's case. It's a little bit of a scary question. All right. Now, usual thing we get to in a unit like this. Stuff people use this for. I'm going to name my lessons as if they were named by Derek Zoolander. This is the Mr. Melville math class for people who want to do math good.
That's so funny.
I like that movie. All right. If you guys are uncomfortable, hi. That's pre-calculus honors.
Ew.
Okay. I'm glad we had that conversation. Now, if you guys are uncomfortable with decimals, percents, and bank accounts, then you need to pay extra close attention. If you're comfortable with those 3 concepts, this may not take that long. For my first example, decimals, percents, and bank accounts.
All things suck.
Percents are okay.
All right, so here's what I'm going to say. Model the situation of $100 placed in a 5% simple interest bank account. Okay, model the situation means write me a fancy math equation.
Is this those things where you have like something over 100 equals something?
No, no, those were good times. Those were simple compared to this. Yeah, they are. Okay, let's try a simple question. Does anyone know after a year, if you put $100 in the bank, how much more money the bank will put on top of that if you have 5% interest? $5, okay? Percent actually means percent. Per means out of. Cent from the Latin is 100.
Okay, what's the thing after place?
Placed in a.
What's 100 sound?
Okay? Percent is out of 100. Okay? So if you have 5% interest and you have $100 in the bank, they give you $5. Banks are generous that way. They want your money. The idea is they're loaning your money out to other people, and they're making money off of those loans, and